We are going live. Okay, I think we are live. Okay, so I am going to get ourselves sorted out here.
And I hear your voice.
Okay. Good evening, everybody, and welcome to another live stream event. My name is Gary Hawkins, and I am joined here with my fellow SDAA member, Dave Decker, who is also the Public Outreach Director for the San Diego Astronomy Association. As some of you are probably aware, I usually go through a brief introduction to sort of set the scene for the live stream event. And then we will actually get into probably two observing sessions because as you'll find out in a few moments, we are going to sort of do a theme for this live streaming event this evening. So Dave, do you want to just say a quick hi and then I'll dive into the presentation?
Yes, welcome everybody to this San Diego Astronomy Association outreach event, virtual. And we are very happy to be out here at the OakOasis County Preserve. The county has been very helpful and working with us, getting us access and power. They're excited to be a partner with us, and we are very excited to have a great place to come out and set up. So let's see what we can do, Gary.
Okay, well, let's see where we go. And as Dave said, we are at the OakOasis Country Preserve, and that is a park run by the San Diego County Parks organization. It's about 400 acres of chaparral and woodlands with a 2.5-mile loop trail that people use during the day. There is some group camping available for youth groups. And the site includes a picnic pavilion and restrooms, tent camping if you're doing the overnight thing, and there's a nice amphitheater here. We're very familiar with this particular spot since we pre-pandemic do our actual in-person public outreach here a number of times during the year. So we're very familiar with this site. But this evening it's just myself and Dave. We're in somewhat dark conditions in a big car park here and a little bit chilly. But we should have a good evening for stargazing, which is what's important. If you're interested in learning more about this particular park, there's a link on the slide, and it's actually just opposite the El Capitan trailhead, which is one of the most difficult hikes in close to the city of San Diego. So it's a nice hike just across the road. Okay, we are in Bortle 6 skies this evening, so we've been able to move slightly away from the light pollution that obviously plagues the city of San Diego and my home observatory location, which is a Bortle 8 location, so pretty poor. So we're in Bortle 6 conditions, and you can see on the map on the screen approximately where we are. Probably about 15 miles inland, I'm guessing, from the Pacific Ocean. Let me just welcome everybody. Sorry, I got slightly out of sync on my slides here. Let me just welcome everybody tonight to the live stream. I am going to give a shout out to a couple of kids organizations that hopefully are on board listening to us this evening, or at least some of them. The first of those is the We Impact Corp. They are a non-profit 501c3 organization that brings STEM education to mid and high schoolers. I've worked with them before in doing presentations for their students, and hopefully some of their students will be joining us this evening. I'm also going to give a shout out to the kindergarten students of Miss Aguilar, room 210. That's at the Elling Browning Scripps Elementary School in San Diego. That's the school that my daughter attends. This is her class, and hopefully she is listening at home with her mum and watching this presentation streamed to the TV on YouTube. So go Penguins for Miss Aguilar's class there for any of you guys listening.
Couple of chats.
Sorry?
I have a couple of chats.
Yeah.
So real quick, a shout out to Jorge from Peru. Let's see, we have DJ from Iowa. We've got Frank from New York. And we have a whole bunch of our locals here. I see Kristen McVeigh is on. She's with the Borrego Springs Library. We will hopefully be setting up an event at her site here in the next 4 weeks or so, and we'll let you know about that one. And good to see everybody else, Woody and Jose, Woody again, and etc. So thank you very much.
Yeah, and I forgot, Dave, you're actually monitoring the chat line tonight. I normally do that myself. So Dave's going to be answering questions for us as we go through the evening. So if you guys have got questions or whatever, please post those on the YouTube chat line and we'll do our best to answer them for you. So the slide that's up on the stream at the moment is the setup for this evening. This is a fairly modest telescope. It's a 8-inch Schmidt-Cassegrain telescope, readily available. And this one's actually quite old. It's circa 1998. Behind that, just to give us a slightly wider field of view, I have a device called a focal reducer. We have, in fact, I've taken the filtering out for this evening since we've got a fairly decent dark sky and I don't need to try and knock the light pollution down. Behind that, I've got a dedicated astro camera, which is a 9-megapixel astro camera. We've also got a digital e-finder that's sitting on top of the telescope, and we'll be just using that. In fact, we can probably take a look through the e-finder at the moment. Hopefully, yeah, there we go. Sorry, actually, I don't think, let me see if I can just transition that. Here we go. Let me just briefly transition that. So here's our e-finder. This is the type of view that we get out of the e-finder. It gives us a wide field view of where the telescope's generally pointing. It's particularly helpful for when we've got lots of obstructions, and it just gives you an idea of where we're kind of slewing in the sky. Right, so back to the equipment setup. And we're basically mounted on a computer-controlled equatorial mount, and that is what's moving the telescope around in the night sky for us this evening. For those who've got a slight technical bent, we're going to be processing the images in a free program called SharpCap. I've actually got the paid version, but it's $15 a year, so it's practically free. This program will take images from our camera. It will take multiple images. Each of the images will be 12 seconds long tonight. We call those subs, so we'll be doing 12-second subs. We align those images so that they can be added together, so it does a star alignment process for the images. And once those images are aligned, they're added together, and you'll see when we're doing this that the noise will kind of drop away and the picture quality will get better. We do a final bit of post-processing, and that's the live picture that we show to you this evening. Because of the type of targets we're going to be looking at tonight, we're going to be able to give you a pretty good feel for each one of the targets in about two minutes generally. There's a couple of targets that are going to require a little bit longer. And yeah, this is a list of hardware and software for those, again, with a technical bent. I won't go into any details at the moment, but it's on the stream there if you guys are looking for technical information about the various software packages and hardware that I have running tonight. Okay, so this evening we thought we'd do a theme. We thought we would do a theme based on the famous astronomer Charles Messier. And Messier, for those of us who are in astronomy, we use the word Messier a lot because there are about 110 objects in the sky called Messier objects, and they're given numbers M1 through to M110. So I guess actually technically that's 111 objects, isn't it?
110.
110? Yeah, okay, 110. Right. And these objects were put together in a catalog, or they've been put together in a catalog called the Messier Catalogue, and it was Charles Messier, which is obviously where the name came from, that started the catalog. And while I think many of us who do some astronomy are familiar with the Messier objects, we may not be quite so familiar with Messier himself. So we thought as we went through this evening, we'd just give you a little bit of information about the astronomer, point out some of the challenges that he would have had at the time that he did his observations, which was a good couple of hundred years ago, and go from there. So, as I said, Charles Messier was a French astronomer. He was born in 1730 and died in 1817. And Messier, at a young age, actually became fascinated with comets. He observed one of the major comets that came through when he was just 14 years of age, and that intrigued him. And that really is what drove his observational career for the next 40 or 50 years, was chasing comets. And he published, he basically, after he finished his schooling and did an apprenticeship and joined the Navy, which is where he was introduced to astronomy, he then did a lot of comet hunting. And in that process, he came across objects in the sky that he knew were not comets. And he didn't want other astronomers to get confused by them. And so he started noting these objects down. And so the Messier Catalogue actually wasn't really a catalogue in so much of targets that he was interested in. It was more a catalogue of targets that he wasn't interested in. And he wanted other people to be aware of those as well if they were doing something similar. And you might say, well, why was he so interested in comets? And one of the reasons was that the early astronomers gained a great deal of notoriety by discovering comets because they were invariably named after them. And so comet hunting in the early days of astronomy was indeed a very popular occupation. Dave, is there anything you'd like to add to that?
Hopefully, towards the end of our evening, we will be able to observe the first list on Messier's items, M1, the Crab Nebula. Hopefully, it will be high enough above the eastern horizon for us to see it. When we get there, I will tell you a story about the naming of M1, the first one on the list, and how he actually came about finding that. It's really a very fascinating story that involves everything from Sir Isaac Newton to Edmund Halley and to some others. But we'll talk about that towards the end of the evening. Hopefully we will be able to actually see the Crab Nebula.
Okay, fantastic. And so just to sort of set the scene where Messier did his observing from, unlike today where we tend, the observatories are invariably in dark areas, dark, remote areas, often on the top of fairly tall mountains. In Messier's day, they didn't suffer from light pollution because obviously the invention of the electric light bulb hadn't occurred. And so anywhere you were in the country that had relatively dark skies. And so Messier was actually did his observing from a hotel in downtown Paris. And he used a number of telescopes of varying sizes. Typically, he is credited with using relatively small refractors of sort of the 4-inch type, 100 millimeters. Again, for those of you that are familiar with telescopes, a 4-inch telescope is a fairly small device. And well, like by comparison, I'm using an 8-inch telescope, and that is actually considered a fairly small telescope. And so with this relatively modest equipment, Charles Messier would spend his evenings looking for these new comets. And as he was going through the night sky, he was finding these objects which weren't comets. And the first version of Messier's catalogue consisted of 45 such objects. And by the 1780, he had actually increased that number to about 80 objects. And obviously, there was no photography at that time, so Messier sketched his objects for others to, and those sketches were then copied in magazines so that others knew that when they were looking at the night skies, that these objects were not comets, but objects of a different type. And because of the relatively small aperture size of the telescope, and also because of the relatively poor materials that these telescopes were made of, what Messier saw often was really diffuse brightness, bright patches in the sky. And so he called these nebulars, and all of the Messier objects in the early days were thought to be nebulars. Of course, now as time's gone on, we found that that's not to be the case, and we will show you this evening that there are indeed a whole a number of different types of objects that fall in the Messier catalogue. Okay, so we're now going to dive into our first observing session. We're going to look at Messier objects that are primarily in the western sky. And the reason that we're doing that is because as the Earth is rotating, those objects are heading closer to the horizon. And so consequently, we will lose sight of them fairly quickly. And then we will continue to get higher and higher in the western sky. And then we will slew the telescope into the eastern sky, where the Messier objects are actually rising, again, because of the effect of the Earth's rotation. And I will now transition across from my slide deck into a view of my observing platform. I'm running this program called SharpCap, as I mentioned before, on a laptop PC. I'm also running some mount control software, and I have an observing list set up, albeit it seems to have disappeared at the moment, but I'll get that back. Oh, there it goes. I have an observing list set up as well that we will be using. And it's gone again. All right, let me see if I can just sort that small problem out. And the first object we're going to look at tonight is M92. So Dave, while I'm sorting out this small technical problem with my observing list, would you like to tell the folks what we're looking at?
Well, M92 is, I call it the other globular in Hercules, since M13 is the famous large bright one. And often when we're doing visual observing, we shoot up to M13, which wows the crowd. They look at it, they're fascinated by this bright cluster of stars, and we seem to pass right by M92. Fortunately, when we have a camera on M92, it makes it look a lot more contrasty, a lot more exciting. So think of M92 as the other glob in Hercules. And Messier's notes, as reported by Stephen James O'Mara, we'll talk about him in a moment. Messier's notes describe this as a nebula that does not contain any stars. How ironic that a globular cluster with a couple 100,000 stars is described as a nebula that does not contain any stars. But this will be a theme as we go through the night when we're looking at objects that actually are a bunch of stars, like galaxies and globular clusters. Messier was not able to discern individual stars when he looked at them visually. So that's mostly because of limitations of his equipment. And these astronomers of the day did not really know what these objects were, so it was easy to describe it as such. And so that's M92.
Okay, and I'm just bringing up, just working with some controls here on the software program. You'll see that I have a histogram. Just bear with us a second. We appear lost, or we lost our network connection to the main PC. So I am trying to determine if we are online.
So the notes say you were talking about looking at the histogram regarding M92 when they dropped out the.
Okay, so let's see, guys. Are we?
We're back.
We are back. Okay, good news. Sorry
Thank
about
you,
that,
Woody.
but it appears that our main laptop got disconnected for some reason there, which was a shame. But we are back, and I will just regather my thoughts here. Right, so, okay, so I need to come back to my... All right. Okay, so comes back. Oh man. Hopefully you can still hear me, but I am
It says lost again. We're buffering.
Is that okay? Yeah, we are having some issues here at the moment.
Okay, we're catching up.
Okay, so I've lost. Okay, okay, so I'm still going. Okay, so hopefully, Dave, does it look like we're going on the monitor yet or not?
Give me a few seconds to catch up. We'll
Okay. Guys, just bear with us a second. Obviously, we had a bit of a systems crash there, and we are waiting to see if everything is reconnecting. Hopefully, it is.
Hearing the audio.
You are hearing the audio. Okay.
Okay,
all right.
Got it back. Yeah.
Okay. We are. Okay, all right. I think I'm getting an error message coming up here on my broadcasting software. Let me just go and check something here to see if I'm set up at the right level here. All right. We normally run at just 30 frames a second, and I am currently showing that, so that is good. I might try and drop my encoder output a little bit here and see if I can see if that will help us a little bit. So I'm doing that now. Let's see if this continues.
Looks like we're okay. We're getting good responses again.
Are we? Okay, good. Okay. Well, I think I was saying there that I was using this histogram to actually control the image or control the uh, image properties in terms of color balance, and also to do what's called stretching, which allows us to vary the dark levels and midtones in order to try and get you the best picture of the object that we're looking at. And I'm hoping that this is indeed working. Are we looking good?
We're looking good.
All right, great. Okay, good. Okay, so we have a fairly decent image now of M92. And just to give you an idea of how big this particular object is, the my screen that's showing here is 1/2 degree by 1/2 degree. So this is probably about 2/10 of a degree. And to put that into some context, the moon would fill this screen completely, almost touching the edges. So it's actually a fairly large target in the night sky, but unfortunately it's considerably dimmer in the moon, and so consequently we can't see it without the aid of a telescope. But we can get an extremely good view of it with an electronically assisted telescope, which is what we have here tonight. Okay, so I am hoping that we're good here. We are wondering what's going on here because
We're good on this monitor.
okay, we're good on the monitor. Right. So that was our first target for this evening, M92. We are now going to go to our next target, which is the Messier object, M57. Assuming that my here we go. All right, so we've now moved to M57. I am going to slew my target to my telescope to M57. And you are seeing on the map now a we've got a unexpected car arrive in our car park. You are seeing on the map now a sky map, and you probably saw that square, this square here, move from M92 up to M57. So we've not moved very far in the sky, and we are now going to save our first image. Okay, we are going to rename for our new target, which is M57, Dave?
M57.
Yep, and I am just going to do something called plate solving to make sure that the target is going to appear in the center of the screen. Hopefully this will not take too long. Okay, so the telescope is now just maneuvering itself so that we'll be perfectly centered, and we are going to clear the last picture, and we're going to start a new stack, which basically means to say that we are going to collect a series of images of the next Messier target, M57, and the software is going to go through and collect those. And this is actually a different object. This is a Planetary Nebula, much smaller than our previous object, but very interesting all the same. So we're just going to give this a few moments to develop. And I'm also going to zoom in as well so that we can get a much clearer picture of this. Now, there are 3 or 4 different types of nebula, and Dave, if I miss one, please sort me out here. We have emission nebula, which are basically areas of dust and gas that emit light. We have reflection nebula, which are areas of dust and gas that are illuminated by stars, and we see that reflected light from the nebula. We have dark nebula, which is actually um, uh, we have dark nebula, which is actually an area of dust or gas that obscures the uh, the objects or the stars behind it. And we have a special type of nebula called planetary nebula. And these are kind of interesting. These are actually stars that have partially um, exploded. They've not gone as far as a supernova, in so much as completely exploded, but they have ejected a large amount of matter in some form of cataclysmic event. And what this does is it creates a spherical um, wave that emanates out from the exploding star, and it forms what are called planetary nebula. So it's essentially a sphere of gas that's moving away from the exploding target, one of which you can see here. This is M57. This is going to be, we're going to see a couple of planetary nebula this evening, and this is the smaller of the two. We're also going to see a nebula called M27. So I'm now just going to do a few adjustments, see if we can get a better picture here. Alrighty. And we've actually now been joined by probably the youngest member of the San Diego Astronomy Association, who was absolutely mortified that her dad did not take her with her this evening. And you can see her little face there appearing. Actually, I don't think you can. Hold on, let me just transition across to, let me give you a, let's get Joy on the screen a second. We'll have a little bit of a, oh, okay, so it's not going to do it there. Okay, we can do it with that one. Okay, so you can see my daughter Joy here now on the screen. She is the sweet child that's been causing her mummy a lot of problems with the yellow hat. Can you say hello to everybody, Joy?
Hello, everybody.
And how old are you?
5.
And are you the youngest member of the San Diego Astronomy Association?
Yes.
Okay. And were you very upset when Daddy left you at home?
Yes.
And did you give Mummy a lot of trouble?
Yes.
And have you forced Mummy to drive you out here into the dark so that you can see what's going on?
Yes.
Okay, jolly good. Well, she's going to be one child that's in a lot of trouble a little later tonight, but that's okay because we love her. Okay, so we'll now go back to the show, and we will go back to M57. And Dave, would you give the folks some information while I try and adjust the image a little bit here?
Sure. M57 is a beautiful, bright planetary nebula, one that's easy to find, and it always displays well. It's not terribly large, especially when you have a camera set up for a half a degree of sky. M57 looks a little bit small in the center of it, but visually M57 always does look very nice. A planetary nebula is what happens to a star, a main sequence, average size star similar to our sun, when it runs out of hydrogen fuel. Stars, of course, they have a lot of hydrogen fuel to begin with, and they fuse hydrogen into helium in the core of the star, creating the heat and the light. And this cycle is what we see as a burning star. So when a star is medium sized, it burns through its hydrogen, creating helium in the core, and it runs out of hydrogen before the helium in the core is large enough to begin fusing heavier elements. So what happens is when the hydrogen runs out, the helium is not fusing anything in the core, and the outward pressure of the star slows down and minimizes, and the core of the star collapses, allowing the outer layers, the atmosphere of the star, to spread out into the universe surrounding it. And that core then becomes a white dwarf, and it is no longer fusing any elements in its core. So that's what we see here. If you actually, I think you can barely see
You can.
the central white
Yep.
dwarf in this image, and which is that tiny little slightly bright dot in the center of that circle. So that would be the white dwarf, and the shells around it are the shells of expanding gas from the original star.
Yeah, and I think we've got a pretty decent image there of the of M57 in a couple of minutes. So I am gonna save that image, and we will.
I can talk about Messier too.
What was that? Sorry.
I was going to say, in Charles Messier's notes, he describes M57 as a patch of light between the stars with rounded borders. It must be composed of very faint stars. Has not been possible to see them. It's a fading planet. So very strange notes come from him. And the odd thing is, we just looked at a globular cluster, which is obviously made of stars, and Messier said that he was not able to see any stars. Now we're looking at a planetary nebula, which is really just a ball of gas, and he says possibly it contains faint stars. So his optics were playing a lot of tricks on him when he was trying to describe these all these items that he saw.
Okay, great. Well, we've now. I'm repositioning the telescope on our next Messier object for the night, which is M56. So I am going to. I've saved my image. I am going to rename my target. I'm going to clear that. And I am going to just make sure that we're in the right place to view the next target, which is M56. So I'm going to do a plate solve here. And plate solving, in fact, I don't need to plate solve. I can see that my target is in the middle of this image already. So I'm going to spare you the plate solve. Plate solving is really interesting. Basically, what it allows us to do is we take a photograph of the sky, and then there is a database that the photograph is compared against, and through some very clever maths, the database allows us to determine exactly where the telescope is pointing in the sky. And if the telescope is not pointing exactly where we anticipate it to be pointing, it then corrects the telescope position to bring the target straight into the center of the image. When you're using a narrow field of view, as I'm using here of about half a degree, a plate solver and the ability to plate solve is actually pretty important to bring these targets into view because we can't see them. You couldn't see these through a finder scope particularly, and so the plate solver then becomes a very important part of the software suite that I'm running here today. So M56 is another globular cluster, considerably smaller than M92, and I'll let Dave give you some facts and figures about this globular cluster as I play around with the histogram here to improve the image.
So M56 was described by Charles Messier as a nebula without a star. So he's getting closer in his descriptions. But the funny thing is, it's truly a globular cluster and not a nebula. So again, he has this confusion here. Interesting thing about M56 is that Messier discovered M56 on the same day that he discovered what he calls the Comet of 1779. So he references everything about in reference to the comets that he's either searching for or has recently discovered, and in the course of those searches, he finds these other objects, and makes these interesting notes. So that's where M56 comes from.
And we have a pretty nice image already on the screen after just a couple of minutes. One of the things about globular clusters is that they do display in a relatively short period of time. So we only need to take about 10 to 12 frames and stack them to get a pretty good representation of the image. And Joy, and my daughter is right next to me here, having come out to see what's going on. What's your favorite object in the sky, sweetie? Do you like globular clusters or do you like nebular? What's your favorite object?
A nebula.
You like nebula. Okay, well, we will be looking at some nebula fairly shortly. So you just stand by here and try and keep warm. She's all dressed up in her hat and her scarf and stuff because it is pretty chilly here tonight. I'm guessing we're probably below 60 now, Dave, probably in the mid 50s. So it's a fairly cool evening here in OakOasis Country Preserve. And Dave, have we got any comments that have coming through on the chat and stuff? I will go to the next target while you're looking at the chat.
A lot of one-line comments. How far are these objects away from Earth? So I haven't checked these object distances, but I would be happy to do so.
While Dave's checking that, and I am slewing the telescope round onto our next target, I can tell you that the first object that we looked at, M92, was from memory 26,000 light years away. So what does that mean? It basically means to say that the light from that first globular cluster that you saw left that globular cluster 26,000 years ago and has been traveling across space until it's managed to hit the lens of my telescope. So you're looking back in history as we look at these objects which are far, far away from us. And to give you an idea, kind of try and put this in some context, while we're talking about distances here and while I'm bringing up the next target. I'm sure most of you can probably imagine what the solar system, kind of got a feel for the solar system, right? We've got the sun, we've got 8 planets that revolve around it. We know that some of those planets are a long, long way away, far further from the sun than the Earth is. And we know that the farthest planet is the dwarf planet Pluto. And Voyager 1 took a number of years, which is the first satellite to actually go past the outer planets, took a number of years to get to that particular planet. So if we now kind of imagine the solar system and we imagine squashing that down, and we take that solar system, which is a huge piece of space, and we squash that down and we make it the size of a 1-cent piece. So we're making it tiny, right? So now the sun is just a speck in the middle of this 1-cent piece, and the planets that are revolving around it are tiny, tiny specks. And we put that 1-cent piece on the 0-yard line of a football pitch. The nearest star to us, which is 4 light years away, which is Alpha Centauri, or the group of Alpha Centauri, that would be basically on the opposing 20-yard line, 260 odd feet away, and that is at a distance of just 4 light years. So now think about 22,000 light years and how far that is away in terms of that little model that we've given you. And that will give you an idea of how distant that target, or at least try and give you an idea of how distant that target is away from us. So we're now looking at M71. Dave, I'm going to play with the histograms again for a couple of seconds. Can you give the folks a quick rundown of the target?
So first of all, to answer the question regarding distances, M57, the Planetary Nebula, is about 1,400 light years away, 1,400. And the globular cluster M56 that we just looked at is about 31,000 light years away. So it gives us an idea about general distances there. Also, I see the comment about relative loudness on the mics. I will try to speak up a little bit on this one to make up for that. Thanks for that.
Are you a little bit quiet on your mic?
We had a comment that yes.
Okay? I'll just adjust the balances a little bit. Okay, you should be a little bit better now.
Okay.
Okay, so we're now looking at M71, and again, it's another globular cluster, and this globular cluster is sitting in a pretty extensive star field, as you can see. We are using approximately the same sort of processing parameters that I was using for the other images, and you can see in this particular image that we have many more stars that are either in front of it or behind it. I will give you some more details about this target in just a second. Quite a lot going on here this evening, so it's proving interesting to try and keep one's thought process going. with my little one sitting next to me who keeps whispering "Daddy, Daddy" in my ear. So
I can give you the some information that comes from Stephen O'Mara, if you like.
Yeah, sure. Why don't you do that, Dave? While yes, why don't you do that?
So I don't know if you visual observers out there are aware of Stephen James O'Mara. He's very well known for his ability to actually see things visually in a scope, and his sketches and his descriptions are phenomenal. He also is an accomplished imager, but we're reading a lot about these objects in a book tonight, written by Stephen James O'Mara, and is simply titled "Deep Sky Companions: The Messier Objects." And it's quite a book. It includes the sketches that O'Mara has made over the years, and his sketches are very interesting because many of these objects, most people, when they sketch these objects, they are very simple little globs with a bunch of dots, not much detail. But O'Mara always seems to find incredible lines and contrast and puts it into his sketches to make them very, very interesting. In fact, his sketch of M71 looks sort of like a tropical fish. And I can see now where he gets that. But if you have not seen his sketching and read his book, I highly recommend it. So M71 is about 13,000 light years away. And it was actually discovered by Pierre Messier, who was a companion of Charles Messier, and they shared a lot of information. The notes in O'Mara's book says that Messier viewed M71 after Messier discovered it and pointed it out to him. And Messier says that it was very faint, and that a slight bit of illumination of his telescope, accidental illumination, causes M71 to disappear from sight. Well, we know about that because we're very familiar with light pollution. But anyway, Pierre Messier was a companion of Messier. He was involved in a lot of his discoveries and recording the discoveries that Messier made himself. So all these interesting points are found in O'Mara's book.
Okay, fantastic, Dave. And my daughter's just whacked me around the head with a level, which we use to set the telescope up initially. And if I catch her in a couple of moments, there's going to be trouble. But as you can see, we've got a pretty nice image of the globular cluster and the surrounding star field now up on the screen for you. So I think it's probably time to save this image and move on to the next object in our tour this evening. And that is going to be when everything on my computer responds, M27. And M27 is a larger planetary nebula. So it's going to be a somewhat larger version of M57 that we saw a few moments ago. So I am just moving the telescope into position now. And let me see if we've got enough up on the screen to show it directly, or whether we need to do some slight readjustment. So again, I'm going to type my name in over there. I'm going to start my new live stack, and we're going to look hopefully at M27. So let's see if this image comes up. And we're taking 12-second subs, so it takes 12 seconds for the first image to come in, and we already have a decent image of M27 beginning to form. So I am now going to do some work on this with the histograms as we collect a few more images. In this particular planetary nebula, much of the description that Dave gave you earlier about how a planetary nebula is formed applies to this particular planetary nebula. But this particular nebula has a slightly different shape to it. It is actually circular, and we will probably see that detail once we've collected a few images. But initially it appears more rectangular, and for that reason is actually called the Dumbo Nebula. Because it has considerably more brightness along one axis than the other. But we will show you that it is actually circular in a few moments. And it's much easier to see the central star in this planetary nebula. In fact, I can already see the central star, which is right here. And so I'm going to do a little bit of work on this now with the histogram. And see if I can improve this image a bit, and Dave will probably give you some more facts and figures about the Dumbo Nebula.
So Messier discovered this object in 1764, and his notes, according to Amira, is that he used a simple 3.5 foot long refractor. So it's very interesting looking through his notes. Many of the notes describe the length of the telescope and nothing else about it. So we don't know the apertures, although we have figured out through other notes the kind and the type of telescopes that they were. Most of the refractors he used were described just by their length. So apparently he understood what that meant, and others at his time period understood that a 3.5 foot refractor was a certain kind of telescope compared to a 1 foot refractor or a 30-foot refractor, which he's used all of those different sizes. But in this case, he was using a 3.5 foot refractor and discovered M27, which of course is another planetary nebula. So O'Mara's sketches are beautiful and somewhat unique. Again, it's worth looking into how he sketches these objects compared to how others do as well.
And we've now got a pretty decent image of M27 up on the screen. You can see the central star, which is right here. I believe it's that one right there. And you can see the pretty clear dumbbell type shape of the red area. And if I'm correct in saying, Dave, red is typically emission from hydrogen and green is typically emission from oxygen. Is that correct?
In general, yes. I can't speak as an expert in that area, but in a little bit of spectroscopy that I've done, the these these types of planetary nebulas show very strong in the O3 emission and the hydrogen alpha emission. So the red would be typically be hydrogen alpha at 656 nanometers, and the green would be about 5,000 angstroms, 5,000 angstroms O3 emission.
Yeah, and what's nice about the type of astronomy we're doing this evening, this electronically assisted astronomy, is that this is a color camera, and these colors are true colors. I can obviously adjust the color balance a little bit, but essentially we are seeing true colors. If you were to actually view this Dumbo Nebula through visually, because of the way your eye reacts when it's dark, you would actually see this pretty much as a black and white image. You might see a little bit of color if your eyes were sensitive enough, but many people will just see a black and white image. So it is nice with the color camera that we can actually see the various colors of the nebula, which in turn then shows us the structure. And I think you can also see now from the image that's formed on the screen, and this is about 4 minutes worth of imaging, you can see the circular nature of the Dumbo Nebula here. The much brighter red area is what we initially saw, but you can now see the green areas, the oxygen emission areas also moving away in this spherical sphere away from the central star. And over time, this will expand. This is a changing nebula. This wavefront is moving out. So if enough years pass, you will actually see that the size of this nebula increases. And often the size of a particular nebula, if it's associated with a planetary nebula or associated with a supernova where a star is actually completely exploded, the size of that nebula will give us some indication of when perhaps that catastrophic event took place on the star. Okay, so that's M27. We're now going to move across to, I think, our first open cluster, which is M29. Assuming that my handwritten notes here align with my... Yes, so we're now going to move to M29. And as we go back to the sky map here, you can see that we're slowly moving higher and higher in the sky here from the western horizon up towards this gray line here, which is essentially what's called the meridian, and that is where the telescope will be pointing almost directly up in the sky, and then we will then start to look at the eastern part of the sky. So we're currently moving up through the western part of the sky. So I'm now going to slew to M29, and you see my telescope moving across to the new target, which I'm now at. So I am going to go back into my imaging software. I am going to save that previous image that we just took there. I am going to rename to my new target, which is M29, and I am going to start my imaging stack again. And I once again will just assume that we're going to end up on target, and if we don't, oh, here we go, we are already on target, so that's good. Okay, and we're not going to need too many images of M29. This is the first example this evening of an open cluster. Open clusters tend to be much younger star clusters. They are star clusters that are loosely gravitationally connected, so the stars are in a group, but they are typically young stars, which tend to be, I believe, Dave, a lot closer to us than your typical globular cluster, right?
In general, an open cluster, uh, in a general way, is sort of a family of stars created in the same star-forming nebula, a star-forming gas cloud. And as those stars mature and the available hydrogen gas is consumed within that cloud, these stars begin to interact gravitationally with each other. They move around a bit. Some are attracted towards each other and then passed and flung out into away from the cluster. And just like the family at home on the farm, they grow up, and many of the kids move away. And in this case, a lot of the stars move out farther from the original cluster. But during this time period, they're in the same general area of space, and they are in sort of the same approximate age. And what we're looking at as young stars, like Gary said, because these are stars that are still in the same region of space as their brothers and sisters where the original gas cloud was. So this is an interesting cluster because it's a very small cluster in general. It's open, and it is an open cluster discovered by Messier again, discovered in 1764. And he describes it as a cluster of 7 or 8 very faint stars. And he again was using his simple 3.5-foot refractor, which is amazing. Now, in O'Mara's book, he says that the cluster actually consists of more like possibly 80 stars. So the difference here is the observing skills and the instruments used by modern astronomers. But here is an open cluster on the Messier list. It is about 4,400 light years away, so more than 4,000.
Yeah, relatively close compared to many of the targets that we've seen already.
Yeah, yes, the globular clusters, because they are in orbit around the center of the galaxy, generally tend to be in the tens of thousands of light years away or more. And these open clusters tend to be closer to us, where we can still recognize them as a cluster.
Okay, and we don't really need to spend a huge amount of time on this type of on this particular target, because it images very quickly. The stars are relatively bright, and as you could see, we got a pretty decent image almost straight away. Now I'm actually going to skip M72 here, and I'm going to move on to M73. M73 is an interesting target, as we will see in a few moments, and my telescope is swinging around onto that target. I just need to be a little careful. Yep, okay, so everything looks good there. So we're now on the target M73. I will do a plate solve here, I think. Let me stop the stack, and let me just go and make sure that we're pointing where we need to be. And to do that, I've just set my plate solver going again. It will take the next image that's captured, which it's done, and it will move the telescope. In fact, we were actually pretty close. We were just 0.6 degrees in error, and we have now got that target in the center of the screen. So I'm going to start my live stack again once I've put in my target name. And I'm going to clear the previous image that we had up there, and this is M73. And we're not going to be looking at this particular image for very long, and it kind of it illustrates, I guess, and I brought it up more because it illustrates one of the unusual things about the Messier list. There are a couple of targets in the Messier list that when you see them, you actually think to yourself, why are they there?
Yeah.
They're actually pretty insignificant groups of stars or whatever, and you honestly wonder why Messier put them in the list in the first place. But he did, and this is one of those examples. M73 actually consists of a group of 4 stars. These are actually not gravitationally connected to each other. And the word I'm looking for here is
It's an asterism.
an asterism. Yes, that is M73. I would like to say in all of its glory, but as you can see, M73, which is these 4 stars right here, is a pretty unassuming target.
In 1780, Messier observed this asterism, and in his notes he says, a cluster of 3 or 4 stars which at first glance resembles a nebula, and which does contain some nebulosity. So the nebulosity probably came from the poor optics in his 3.5-foot refractor. So, and he's interpreted that as nebulosity, and thinking originally that the stars were together and actually was a single unit. But clearly he says it's a group of 3 or 4 stars. The interesting thing here, O'Meara has actually sketched this asterism, and his notes are fascinating. And I will read a little piece of his notes here. O'Meara says that when he's looking at this asterism, and looks at it for a while, he says it transforms into a Flash Gordon rocket ship sailing through interstellar space with the 2 brighter stars in the Y are the rockets. So his sketch looks like a rocket ship, and that's sort of Stephen James O'Meara's fantasy about this asterism.
And often when various astronomers describe these things, like the Owl Nebula definitely looks like an owl. How you would find a rocket ship in this, I'm not really too sure, but apparently that's what was seen. So anyway, that is M73. So moving quickly along, I am now going to take us to our next target, which is M15. And I believe, am I correct in saying this is another globular?
I'm sorry, we are going to where?
M15?
Oh, 15 is a beautiful globular cluster, yes.
Okay, so I am going to, we were already on, I moved the scope while we were talking about M73, and I am now going to take us to M15, and we have our first image appearing here. And as Dave said, it is a beautiful, another example of a beautiful globular cluster. So my daughter here, who's now managed to, oh, she brought popcorn. Were you planning to share the popcorn with anybody, or are you just planning to eat the popcorn by yourself? Are you going to share that?
Eat it.
Oh, thank you very much, Joy. That's great. So our third member here, who has obviously got bored with the is now just treating this as a movie event. Okay, I like the popcorn. Did Mummy bring that for you? Lucky you. Okay. So Joy, just to give you, she's been pretty interested in astronomy since she was fairly young. We have the solar system up on her bedroom, and we have the major constellations in her bedroom as well, with these fluorescent stick-on things. It looks pretty cool, actually, and you're actually pretty good at recognizing some of the constellations, aren't you? Particularly Orion, and you know that one, and you know the W, don't you? That's Cassiopeia. Yes, that's right, the W or the M. She's getting her feet sorted out here. But here we have, as Dave said, a spectacular globular cluster. This is M15, and I will hand it over to Dave for a few comments while I bring up some information as well.
So in 1764, Messier observed this globular cluster, and he described it as a nebula without a star between the head of Pegasus and that of, I'm not sure how to say it, Aquarius. He says it's circular and that the center is bright and doesn't say a whole lot more about it. It seems to me that he would recognize that it was very bright, but he didn't really say that. Now later on in his notes, Messier said that it's sort of a nebulous area, or possibly a nebulous star, and consists of several stars. So I'm not sure what he was looking at, what kind of instrument he used in his second notes, but obviously he used a different instrument and had a different view, which is interesting because Messier did have at least a dozen or so telescopes of various kinds that he used during his observing sessions. Most of them were refractors and very long focal length and very small aperture. And a few of them were Newtonian style telescopes of fairly large aperture, up to 7 and 8 inches in aperture. The problem, of course, with the Newtonian telescopes of that era is that the mirrors were made of speculum metal, which was a metal that was forged for this purpose and then highly polished. And of course it would tarnish often and have to be polished again. So if you think about a reflector telescope like the Newtonian with a metal or a metallic main mirror and probably a metallic secondary mirror, these two mirrors did not reflect a high percentage of the actual light. It wasn't until about 1860 or 1870 that I'm not sure, it might have been Flamsteed, I'm not sure who it was that brought the glass telescope mirrors into existence. And then, of course, the vision on the reflector telescopes improved vastly. But that's Messier's notes on M15. Gary?
Yes, which, as you can see, is which we have up on the screen now. And in fact, I might just transition this to a, if I can, getting confused by my own broadcasting software here. So I'll just bring up a standalone image there of M15. And as you can see, that's a pretty spectacular globular cluster. But again, going back to the age of these particular globular clusters, you can see that this consists of many yellow to red stars, as opposed to the much younger white stars, which are much younger in the sort of star evolution sequence. Again, which gives you an indication. They often say that globular clusters are the grandfathers of a galaxy. Anyway, we have a nice picture there of M52. So Dave, we've been running about 75 minutes here at the moment. I think I'm going to bring up the, I think I'm going to skip a couple here, perhaps bring up the Open Cluster M52.
Okay.
And then we'll go after our first comet, which sort of kind of ties back into Charles Messier. So let me bring up M52 here. We are going to skip across. I've lost my mouse again. There we go. We are going to skip across M2, which in itself is another spectacular globular cluster, but we have seen quite a few globular clusters so far. So let us move on to M52. Here we go. And we have just crossed the meridian, as you can probably see from my star map there. So we're keeping an eye on the telescope because as the actually, I don't think we did cross, do we? We're okay because when we do a meridian flip, as it's called, all the cables, we just have to make sure that the cables don't snag. So we're now on M52. I am going to bring up this cluster First of all, I am going to save the image that we got of M15. And what I like to do is I actually have a database of all the targets that I've ever imaged with EAA. And I will usually at the end of an evening or usually tomorrow, will compare the images that I've got this evening with the images that I've got in the past and keep the best of those images so that on evenings when the conditions are not proving to be as good as they are tonight, we've got other stuff to look at. So we're now going to go to M52. Well, we're actually slewed there. I am going to do a plate solve just to make sure that we are the telescope is pointing in the right direction. So we're just going to go and grab the sub necessary to do that. And hopefully, yeah, we're just maneuvering. Scope's going to maneuver position. Did the scope move, Dave? It must have done. Okay. I didn't hear it move, but I presume we did move. Let me start. Yes, it did move. Let me start the live stack here. And okay, so I'm on M52. I need to clear my previous image, and I am going to need to call for Mum here, as my little one here is now suffering from the cold, which of course Dad told her it was going to be very cold out here tonight, which is one of the reasons he wanted her to watch it on the TV at home. And now she's feeling just how cold it is out here in the middle of nowhere. Aren't you, Joy? Are you cold? Would you like to tell everybody how cold you are?
A lot colder than when I was in the house.
Yes, which is why Daddy suggested that you watch this on YouTube, right? But apparently that wasn't going to work, so Mummy had to drive you all the way out here, didn't she? Yes. But as the youngest member of the San Diego Astronomy Association, we'll let you off with that. Right, so here we have the Open Cluster M52. Let me just adjust the histogram a bit so that we can see it in a little bit more detail. Again, it's one of those images that we're not going to have to stay on particularly long because the stars are relatively bright, but I will try and give us a fairly decent rendition of M52 there. So let me just bring that up a little bit in size so that you can see it. And we will go from there.
So the M52 is an open cluster. It is about 5,000 light years away. And as we discussed earlier, open clusters are generally a family of stars created in a cloud, and so they're related to each other, and they're usually younger stars. In Messier's notes, he says that this cluster, it's a cluster of very faint stars mingled with nebulosity, which may be seen only with an achromatic refractor. It was while observing the comet of 1774 that he discovered this open cluster. So he actually refers to using an achromatic refractor, which was the only way he was able to see the nebulosity. So I'm not sure exactly how that pertains to the scopes he's actually using. But in that time period, they had invented and were actually using a refractor that had some ability to control the chromatic aberration of lenses. And this chromatic aberration, of course, was the main motivation to develop a mirror-based telescope, because mirrors do not create chromatic aberrations. So in this case, Messier actually said that he could only see the nebulosity with an achromatic refractor. Very kind of a strange situation.
Okay, great. And I just delivered my My little one there, back to her mum, who's, I think she was beginning to suffer from the cold. So they're now sitting in a nicely heated car, and hopefully we will be able to continue without further interruption. I tell you, they say you should never work with animals and children, and there's a good example of why you shouldn't be working with a child. Right, so we've now looked, and this is a pretty spectacular open cluster. It consists of about 200 stars. And I'm not sure if Dave mentioned, we are at the western edge of the constellation of Cassiopeia. So we're moving across the night sky here now towards the east. The cluster is approximately 4,000 to 5,000 light years away. So again, relatively close compared to some of the other objects that we've seen. And we are going to be seeing some more distant objects very shortly because we will soon be looking at our first galaxies. But before we do that, we are going to try and image a comet. And this kind of ties back nicely to Messier's primary interest, which was searching for comets. And since there are a couple of comets in the night sky this evening, we thought we would try and image those. So the first thing I'm going to do here is I am just going to go into my observing list, which is here. And I'm going to update the coordinates because comets obviously move. And I want to make sure that we are going to hit this target. So that should have done an update. I am going to slew the telescope to the Comet 156P Russell Linear, and the people that discovered this particular comet would be Russell. I'm not sure where the linear piece comes from, and my friend in England, who I'm not sure if he's on tonight, Ross, because I haven't been able to see the chat window to see if he's on, but he did say he might. Ross, is there a Ross on there?
Ron Gross?
No, Ross.
Oh, no, I don't see a Ross.
Okay, Ross runs the Bolton Astronomy Association, and he is also interested in comets, and he was the one that suggested that we take a look at this particular comet. Now, I will say a couple of things as we get into this. First of all, oh, that's interesting. Where? Okay, well, wow. That's kind of interesting, Dave. That is the view from my e-finder at the moment. We're pointing pretty much up in the sky. What is... Oh, is that... Where is this light coming from? Is that... I think that must be coming from some of our lights that we have here. Okay. Anyway.
I don't know.
Okay. Right. Yeah, I think that's our lights here, Dave. Okay, so... So apparently my daughter is heading home now. The evening got a little bit too cold for her. So let me... Yeah, neither do I at the moment. Okay, so first of all, I'm going to do a plate solve to make sure that we're in the right part of the sky. So let's do that. And we are now going to try and see if we can see this comet. So what we're going to be looking for here is a slowly moving object going through a static star field. And that's how we're going to know it's a comet. We're not actually going to be able to image the comet like you would see it if you were able to photograph it and see the tail and stuff like that, because in order to do that, we would actually need to do quite a bit of post-processing of the image, and obviously we can't do that while we're doing this online. But what we are going to look for is we're going to look for the trail of the comet across the sky, and if we image for about 5 minutes here, we should be able to do that. But before I do that, I'm going to need to just try and get this telescope to work out if it's pointing in the right direction, because my first plate solve failed. So I'm just giving it a little bit more gain on the camera, and let's see if it gets it this time around. Yes, so we are now going to plate solve, and the telescope has just moved, so we should be right on top of this comet. It should appear in the center of the screen, and let me see if I can image it now. Right, so let me just save that picture of M52, which was the open star cluster that we were looking at a few moments ago, and now we are going to look at 156p. Right, so let's reset our stack and see what we get. Now, interestingly enough, it looks as though we may have actually, on that first sub, actually have picked up a satellite going across the image due to that line there, and you can tell that's a satellite and not a comet, because it's moved such a significant period, a significant distance in a short period of time. Okay, let's see if we can get some. That's not good. No, definitely not. It should be right in the center. And we're not going to see it for until we get some stacks sorted out here. So let's just. Now, what's interesting here, let's just bring this image up full scale. I'm hoping that we're going to see the comet right here, and this over a period of time should develop into like a straight line. And if that develops into a straight line, then that's the comet against our star field. But what's interesting here is, as we wait for this image to form, is that we've ended up in a part of a sky where we're actually seeing what appear to be a couple of galaxies. I would imagine that that's a galaxy right there. That looks like a galaxy. I mean, these are small galaxies, but those look that looks pretty much like an edge-on galaxy there, and it looks like another edge-on galaxy there. And I'm guessing that this is some sort of nebula up here as well. So it will be interesting to see what forms over the next couple of minutes. And we're going to need about, well, certainly the last time I did this to give it a try, I needed about 5 minutes of imaging to see the straight line forming. So I'm kind of hoping, although I don't see much happening at the moment, that we're going to see where this comet is. So just be patient with us for a second here as these images form, and hopefully we'll have hit this comet. If not, we will go on to our next target. And in fact, while I'm waiting to see what happens there, let me see where we are. Okay, right. So we may just, Actually, while we're waiting to see if this comet forms, I am going to step away. I'm going to transition over to my presentation again, just to give you a little bit more information about Messier and the later versions of the Messier catalog. So let me do that now, and we'll come back to our image that we're still stacking in the background here in a few moments and see what we've actually got. Right, so the final version of the Messier catalog that Messier published was in the French, one of the French magazines in 1784, and that actually contained 103 of the 110 Messier objects. But what's interesting is that after his death, and when people actually started to go back through his notes that he had put together, and also the notes of one of his observing companions, Michel, it became clear as well that they'd actually seen a few more objects that also kind of fell into the same category. And so objects were then added, not very many objects, a further 7 objects were added in later years. The last one being, I believe, in 1967?
1967, yes.
Was the last, which was M110. And so the Messier catalog that we know today as astronomers consists of 110 objects, but Messier himself only put 103 of those objects in the catalog before his death. Anything you want to add to that?
I think the reason later astronomers ventured to add objects to his list is that they found descriptions of these objects in Messier's notes. And even though he did not list them specifically as an item, they were described sufficiently for someone to say, well, we believe he actually saw this object. He just did not put it on his list. He did not designate it as such. So that was a situation with M110, which obviously is the very large, somewhat dim galaxy companion to M31. And in Messier's notes, he describes M31 and M32, and with his telescopes, he most certainly should have seen some indication of M110 at the same time. So that was why they felt they could add M110 to the list, because his description, Messier's descriptions of what he saw actually described what an early view of M110 would be. And that was the same thinking for the other objects added beyond 103. As a quick note, while we're trying to bring up this comet, another very interesting study is to take a look at what William Herschel did with the Messier objects, because William and Caroline actually did observe the Messier objects, and there's quite a few notes came from the Herschels regarding their interpretation of Messier's objects. Now, the Herschels obviously were very sophisticated designers of telescopes. They were still using speculum mirrors, but they were doing a much better job of casting and polishing the mirrors, and were much better had much better technology and skill at observing these objects. So if you're looking for something to do some night, go look up what the Herschels said about the Messier objects. It makes a very fascinating read. Gary, how's that coming?
Well, unfortunately, Gary missed the target. Apparently, because I do not see, and I can transition back to my screen here. Hold on one second. I do not see my comet forming, which is somewhat disappointing. I do see in the screen, I definitely see an edge on Galaxy, and I'm pretty sure that I've got a second galaxy here, and I've definitely got some nebulosity forming. And if we weren't looking at Messier objects, we could probably identify what these targets are. But I have completely, I do not see my comet, which I was hoping to see as a straight line. So I think we'll move on from this particular one. We've got one more comet that I'm hoping that we're going to be able to see towards the end of the evening. And I think what we'll go and do now, Dave, is actually go look at Messier Object 110, the final one. And
it would be nice if we could do M1. So we'll have to see.
Oh,
if it
yes, we will
clears.
definitely not miss M1.
That's a
Yes.
very fascinating tale. So,
Yes,
in
absolutely.
the meantime, Woody did say that he saw the galaxy in your image.
Yes,
So,
yes.
yeah.
Yeah, I could see the galaxy was beginning to form quite nicely there.
We're doing a flip.
We are actually doing a Meridian Flip now. So our telescope now is actually slewing almost, I think we're good, Dave. Our telescope is slewing through about 180 degrees here now as we do what's called a Meridian Flip. So it's just going to take a moment here, and perhaps I can... you can actually see the scope slewing here on the E-finder as it slews into position, and the scope has now positioned itself. So we definitely will need to, so first of all, we need to go to the big image, the big camera. Let's save that image, and I'll see if I can work out later what happened there. And I will invariably need to do a plate solve here, because since I did a Meridian Flip, it's in all likelihood we're going to be off by a little bit here. So let's see if we can do that. And one of the things that I am finding again tonight, and it obviously is going to require a little bit more work here, is that I'm definitely hitting CPU overload here. The things are not responding as fast as they could or should be responding. So that was probably what caused us to have a slight technical problem earlier on. So we've done our plate solve. The telescope has repositioned itself by about 1/4 degree, and I will clear my stack. I will add my target name in. And actually, I'll clear that stack again. And M110 is going to be our first galaxy that we see this evening. So everything that we've seen so far has been within our own galaxy, the Milky Way. What we're now going to do is we're going to look at a couple of galaxies that are beyond the Milky Way. We're going to look at M110 first, and then I'm going to show you the core of M31. And then we'll probably go and look at M33, because that is a beautiful galaxy in itself. And then we'll probably pick a few final targets to finish up with here. But here is M110. It's beginning to stack. I need to do some adjustments here on the color. Okay. And M110 is part of what's called the local group of galaxies. This is a group of about 7 or so galaxies that are actually located fairly close to us. And when I say fairly close, I'm talking in the order of about 2.3 million light years. And there are 3 galaxies that are often imaged together. M110 M32 and the Andromeda Galaxy, which is a huge galaxy. And so M110 and M32 are considered as satellite galaxies to the M31 Andromeda Galaxy, which is by far the largest galaxy that's viewable in the sky. And again, this was discovered by Messier, although didn't appear in the original Messier lists. It wasn't until 1967 that by going back through the notes of Messier and Michel, that they realized that he had actually seen and catalogued this object, and so it was later added to the Messier list. And in fact, it's the last of the Messier targets.
I might add that in the O'Mara book, he credits Messier with observing 110 in 1773. So apparently he was able to read some notes that convinced him that Messier did see it.
Yes, and in fact, that's the notes that I have here as well indicate the same thing. But obviously, at the time, Messier did not include that in the catalogue that was published in 1784, but it was later. He was later given credit for that indeed. Right. So here is M110, and I just pressed the color balance there, and it immediately did something I didn't really want it to do. So let me just try and grapple with the color. What I like to do when I'm showing these images is to basically align my red, green, and blue channels. I tend to find that gives, let's say, the most realistic real color interpretation of the object that we're looking at. That's what I'm trying to do here, although my computer is reacting somewhat slowly. So here we see this elliptical galaxy, M110. The stars that you see here are stars in our Milky Way. So we're actually looking out through our own Milky Way, looking past stars that are in our Milky Way, and we're looking out at the galaxy beyond. Now, the galaxy is so far away, 2.3 million light years, that with this type of telescope, it's impossible to actually determine individual stars. All you see is a haze of light that forms the actual shape of the galaxy. And for this particular galaxy, which is an elliptical galaxy, there's not much in the way of structure. The galaxy that we'll show you, M31, in a few moments, you'll actually see there is distinct structure in that galaxy. Anything you want to add about M110 there?
I might mention for you visual observers out there, a quick glance at this image that Gary just pulled up. You might think, oh, we're actually looking at M31 and with a wide-angle eyepiece. But in fact, the field of view of this camera is only 1/2 degree by 1/2 degree. And if you check the star pattern, you realize this actually is M110 by itself. You're not seeing M31.
Yeah, and often, and I've just dropped this image into black and white as well. When we're observing galaxies, it's often, it does give us an advantage to view the galaxy in both black and white and color. We do tend to see some features in black and white that you wouldn't necessarily show up quite so prominently on the color version. We start to see some dust lanes and stuff like that. So I just thought I'd give you a quick black and white image here. And you can see this galaxy, which I believe is in the order of about 12,000 light years across, is taking up about 0.2 of a degree in my field of view here. And you'll see when we step to M31 in a couple of minutes, and that the M31 is going to fill the entire screen here. Okay, so I think we've got a decent image of M110 there, which is the last of the Messier objects. So once again, I will save that object. I will go to my tour that I set up and I will step on. I think we'll skip M32 because it actually does look pretty much like M110, and we'll go straight to the Andromeda Galaxy, which is of the three galaxies here, is by far the largest, M110 and M32 being considered satellite galaxies. The scope moved very little because these three galaxies are literally in very close proximity to each other. So we should be able to go back into our main viewing screen. I will add my target name and I will reset my stack so that we see this new image, and you'll see what a difference we have here in terms of what we're viewing. So hopefully the first image of the Andromeda Galaxy will show up and here we go. So I think you can already see that this galaxy, in comparison to M110 and also M32, is huge. And in fact, we are only seeing about 1/6 of the long axis of the galaxy in this picture. Maybe a tiny bit more because it's actually, fortunately enough, sitting right on the diagonal of my camera. But we are probably seeing about a fifth to a quarter of it. The actual galaxy itself is about 3 to 4 degrees across. So if you were actually able to see this, if it had the same visual intensity as the moon, this would be by far the largest object you would see in the night sky. But of course, it doesn't have anything like that visual intensity, and so consequently, you can't really see it with the naked eye. Although, if you're in a really good dark sky location, you can just make it out as a kind of fuzzy blob. But here you have a pretty spectacular image in the first few frames of the central core of M31. And you can immediately see in this image the dust lanes associated with the spiral nature of this galaxy. You can see an inner lane very clearly here. You can see another lane out here. There is another lane here. And this galaxy is basically a big oval-shaped galaxy that is almost lying, going from top left to bottom right. You're seeing the core of this galaxy, and that's a pretty spectacular image there of the central part of M31, which is 2.3 million light years away. So that image again is going back in history. You're looking at light that's arriving that left this galaxy 2.3 million light years 2.3 million years ago, a considerable period of time. Okay, I'm going to put some color on this, I think.
And while you do that,
Yeah.
a few comments from O'Mara's book. He says that Messier observed this object in 1764, described it as a beautiful nebula in the belt of Andromeda, shaped like a spindle. Examined it with several instruments, but was not able to detect any stars. It resembles two cones or pyramids of light joined at their bases, and the axis of which lies northwest to southeast. The 2 points of light are perhaps some 40 minutes of arc apart. The common base of the two pyramids is about 15 minutes. So he made a pretty good description of the shape and the size and the direction of the main axis, and That's very interesting. He examined it with several different instruments. I would like to know which ones they were, but that's out of Amira's book regarding Messier's notes on M31.
Yeah, and we've got a really nice image. I think this is probably one of the nicest images I've collected of M31 so far. The dust lanes are particularly prominent. We are seeing quite a lot of detail. This is actually photographically a quite difficult object due to the brightness of the central core. And so in order to, the guys who do astrophotography have to do quite a lot of work to really show this to its full extent. But I mean, considering that we've stacked about 4 minutes worth of images. That is a pretty impressive rendition of M31. Again, all the stars that you're seeing here are all foreground stars. These are stars in our own galaxy, the Milky Way. You are seeing no individual stars within Andromeda because of its a significant distance away from us. And just to give sort of give you another perspective, while this might be 2.3 million light years away, in the scheme of things, if we go back to our analogy of the football pitch, we really are, we're obviously a lot further away, but considering the overall size of the universe, which is the observable universe is currently 13.3 billion light years. When you consider that this object is 2.3 million light years away, you're really, although it sounds like a long way, you're actually we're only viewing objects which are relatively close to us compared to the overall size of the universe. And really, it's not possible, particularly with a telescope like this, to see objects much more than a couple of 100 million light years away. So we're really only skimming the surface of what is out there in terms of the universe as we know it today. But that is a pretty spectacular image. These dust lanes are showing up really well here, so I'm going to definitely save this image because I'm pretty pleased with that one. So let me save that. And we are almost 2 hours into our live stream here at the moment. So I think I'm going to jump on a little bit here, and I think I'm going to go to M1 so that we can get to M1, which...
M1 should be well placed right now. It's about
right.
25 degrees above the horizon, and it's clear over there. And the other object, if we had time, would be M33, also as well. So
yeah, we should
perhaps we should do M33 first, and then M31, and then M1.
Yeah, let's do that. So let me go into my sky map. I can actually close my tour down and go straight to M33. Okay, so there we go. So now we are we're in the western sky. We're in the eastern sky now. And we are slowly heading towards the horizon, but we're still actually fairly high in the sky. And so what we're looking at here is another galaxy, which shows particularly well. So let us, let me get my parameters set up here. Let me just make sure that we're on the target. And I can tell you, for those online, I hope you are taking the advantage of viewing this in a nice warm room, because it is getting pretty chilly out here tonight, Dave.
It's a little chilly. I have to check the thermometer. You're headed at 33, right?
Yeah, going to 33 right now. And actually, I was practically smack on top of it. So my telescope is just adjusting itself. I am going to clear the picture of M31 and I'm going to bring up M33. And M33 is a beautiful spiral galaxy which fits really well in the field of view of this telescope. So that's why Dave wanted me to show that to you. I'm going to need to restack that. Let's just clear that again. Sometimes it takes the telescope a few moments to settle. So, and you can tell that you get streaks on the image as I did there. So I just let that settle a minute. And let's just, here we go. Yes. All right. So we're now going to be looking at what's called either the pinwheel or triangulum galaxy, M33. And we'll just let this take a few images. And I guess luckily enough, Dave, I've managed to get this right on the diagonal again as well, which is going to actually result in a really nice image here. So we're just going to capture some frames, and I'm going to zoom in here. Just to give you an idea of what's going on. So we're now kind of like zoomed in towards the center here. And as you see that we capture some extra frames here, just keep an eye on the sort of noise. And you should see this noise level drop away a little bit, assuming that I've got that. Let's probably wander out here a little bit. Each time we add a frame, of course, this may not happen, but hopefully it will. Usually it's a bit more apparent than this, but I guess I must have the histogram controls a little off at the moment. That didn't quite show as I wanted it to. Anyway, we'll zoom back out again, and we'll bring this up full screen. Oh, my daughter's just got home.
Oh.
I can tell that because my alarm system is reporting once again that somebody is going through the front door. So my daughter's obviously got back home. Yeah, and we've got a really nice image forming here of M33. And I haven't even played with the histogram here. So let me just play with this a little bit and see if I can make an even better job of this. So I'm just doing a bit of manual color balancing just to try and bring these peaks somewhat together. And let me, it's probably a little bit, let's leave that there and shift that black level in there. And this target, this galaxy, which is a spiral galaxy, really, as you can see here, is pretty much full frame. So again, kind of, about the size of the moon. I mean, the moon basically fills this camera lens with this setup, full frame. And you can see our spiral galaxy here is pretty much full frame. It's not in this direction, but it is here. And you can see the spiral nature of this galaxy. You can see the spiral arms here radiating out and what's causing this is that the center of the galaxy is spinning at a different rate to the as we go to the further elements of the galaxy, and it creates these sweeping spiral arms. And you can actually see that the galaxy is rotating in this direction. Now, Dave, while this is forming, and a question, and I really must put this into one of the online plate solvers to identify the targets around it. Do you have any idea, if you looked at this galaxy, there's kind of a nodule or bright spot in the sort of upper right left-hand corner? Have you any idea what that might be?
Actually, yes, there's several knots of nebulosity that are pretty prominent. That one large reddish knot of nebulosity is pretty well known. It has its own number. I want to say NGC 604, probably documented by the Herschels, but I don't think Messier was able to see it. But yeah, there's several knots of star-forming regions, mostly nebulosity, and I don't know all the actual details, but it has a lot of detail, a lot of contrast in general.
Yeah, yeah, I've noticed that. Well, every time I've observed it, I've noticed it, and I've kind of wondered what that actually was, and it's showing up pretty well this evening.
I can tell you what Messier said.
Oh, okay.
So according to Mira's notes on Messier, he observed M33 in 1764, and he said that it's a nebula between the head of the northern fish in Pisces and Triangulum, close to a 6th magnitude star. The nebula's light is whitish and almost even in density, but is slightly brighter over the central 2/3 of its diameter, and it does not contain any stars. It is difficult to see with a simple 1-foot refractor. Its position was determined relative to Alpha Triangulum. So here he's looking at one of the most fabulous galaxies, and he says that does not contain any stars. It's so funny that he says this, makes this comment over and over again about things that we now know have millions of stars in them. So anyway, that was Messier's notes on M33.
Well, and not even millions, actually, right, Dave? I would imagine that the star count is probably around 1 billion, right?
It's hard to say. I don't know the actual numbers. I know M33 is much smaller than M31.
Okay, right, right. But yes, we're certainly looking at an object that has hundreds of millions, if not billions, of stars in it. And there are indeed estimated to be more than 1 billion galaxies, right, in the in the total universe as we kind of know it today.
Easily.
Yes.
Yeah.
So if you can imagine that is a billion stars in 1 billion different galaxies, that is a number that's way too large to calculate at this time of night. And so we've got a really nice image here of M33 this evening. I'm actually going to go into my stack here and save it. And I'm just then going to bring it up in black and white as well, just so that we can, well, actually I want to save it in black and white as well so that we can just take a quick look, see if it looks any different. Okay, so we've now gone into black and white. And typically with the black and white, you tend to see a little bit more of the structure. So the arms, the spiral arms are showing perhaps a little clearer here. You can see another spiral arm here. You can see a sweeping spiral arm here. You can see another spiral arm, which includes the area of nebulosity that we were talking about a few moments ago. And you can see the arms on this side as well. And again, that's a pretty spectacular image.
So Gary, in the chat, Ken Hodling noticed that, or commented that it contains tens of billions of stars.
Tens of billions of stars, yes. So, yes, so immense number of stars.
Now he says 200 billion. 200
billion, wow. It's pretty incredible. And that is a pretty spectacular image. Let me just transition. There we go. Let me just bring that back to full screen. Okay, so let's go to M1, I think.
M1.
We
Yes.
are heading towards the end of our evening here. I think we're probably going to do M1, and I guess I'm going to see if I can finish off with a comet.
If you can find one.
If I can find one. I guess, I mean, we've got 2 chances. I guess we can try it. But before we go comet hunting one more time, just to really recognize what Messier was well, what he wanted to be famous for, as opposed to what he ended up being famous for, which was the Messier list. Let us go view M1, which is the Crab Nebula, and kind of different to the targets that we've looked at this evening. Just waiting for my. Okay, come on. Yeah, it's interesting this evening. Yeah, come on. My computer is definitely overloaded here again. It is struggling to respond to my mouse commands here. So let's just hope that we can bring this to an end in a spectacular fashion as opposed to the damp squid ending, which will occur if I can't get something to work here. All right, let's see if I can. All right, nothing is operating. All right, I am going to go into. Let me close that one down because we don't need that anymore. Let's see if that helps. Okay, so I can bring the target up here as well. So let me bring up M1. And this is one of the advantages of having several pieces of mount control software running is if one fails, then you can go to the second one, which I don't particularly like, but it works, or it's certainly working at the moment. So we are just slewing to the target M1, which, as Dave said, is fairly low on the horizon. And yeah, we got a slight cable problem there, Dave.
It should be 35 degrees.
All right. I am just going to have to step away from the headset for just 1 second here. I've got a slight cable problem that I need to resolve. So just 1 second, and we'll be. Uh, can you see what's happened there, Dave? Yeah, that needs to come up. Yep, you got it. And it just needs to sit. The power. That's right. Just needs to sit on that platform. It fell off. It just rests there. Yeah, it's a little precarious, but it kind of works most of the time. All right, that's good. All right. Yeah, my cooler power supply there for the camera. This is a cooled camera. Detached itself from the mount. Anyway, going back to where we were. So I am now slewed onto M1. I am going to do a plate solve, I think, just to make sure that we're there, because we did actually move the mount some distance. So let's capture an image and see what happens. And we weren't too far away, about 0.1 of a degree off, which was actually within the field of view, but we're now going to bring the target into the center. So I'm going to bring my live stack up. I'm going to clear from my previous image of M33, and hopefully we'll grab this first image of M1. Okay, and I'm just going to need to clear that again. This is kind of nice because we've seen the last of the Messier objects, which was M110, and now we're going to see the very first Messier object that Charles Messier found. And once we begin to image this here, I will hand over to Dave, and he will give us some of the history behind the first Messier object. So yeah, I'll hand it over to you at this point there.
So M1 is in fact a supernova remnant, and in itself it has quite a history. The supernova was observed in 1054 AD, and we have good historical records from the Chinese astronomers. And the Chinese astronomers said that this supernova was so bright that it was visible in daylight for 23 days, that it was brighter than Venus, and it made quite a big impression. They said it was visible in the night sky for 653 days. So it was a big, bright, major supernova that those looking at the sky saw and recognized. There's even some indication that the petroglyphs found in Navajo Canyon in the White Mesa area in Arizona, Chaco Canyon National Park, indicate that Native Americans may have actually observed and recorded this event in 1054 AD. So it was seen, and very obvious sky event, which had a large impact on many societies. So that's where in 1054, that's where the supernova came from. That supernova remnant is now known as M1, and it's in the constellation of Taurus, close to Aldebaran. And that's what Gary is beginning to image here. So, interesting thing about the supernova remnant is that it was in an area of the sky that Messier was looking for a comet in 1758. Well, that comet is another piece of interesting history, now known as Halley's Comet. Edmund Halley had been looking at records of comet observations, and he realized that a great comet had been observed in the years of 1531, 1607, and 1682. So Halley assembled some friends, including, I believe, John Flamsteed, and they began to make some calculations, and Edmund Halley made a prediction that this comet would return and would be seen in 1758. Well, this is rather interesting because no one had really realized that comets could be periodic, that they could actually return. So it was a pretty big step for Halley to make this prediction about the return in 1758. Well, naturally, long time later, Messier, being familiar with comets and comet history, knew about Edmund Halley's prediction of the return of the Great Comet in 1758, and Messier referred to it as the Great Comet of 1758. So he's looking for this comet. It's supposed to be in Taurus, and while he's looking for it, he stumbles across this supernova remnant. Initially, he thought it was a comet, but he watched it for a while and it was not moving. So then he realized this is not a comet. And this was the beginning of Messier's list. He said, okay, I've observed this interesting thing, and that's great. I should make a note of it, but it's not a comet, so I'm not going to call it as such. So he started a list, and it became Messier object number 1, the first thing he wanted to make a list of that was not a comet. And he did so. The interesting thing was that the prediction about the Great Comet of 1758 was a little bit off by a couple of months, and Messier did then observe it, I believe, in January of 1759. But in the meantime, while he's looking for it in 1758, according to the prediction, he stumbles across the Crab Nebula. And that's the beginning of Messier's interesting list.
And we have an image on the screen. I can't say it is the best image that I've ever produced of M1. I think the problem is it's probably a little bit low on the horizon for us, and we're looking through a lot of atmosphere. and so it's kind of giving it this yellowish tint. Normally this shows in, and you can kind of see the colors a little bit. Normally it shows in very vivid reds and greens, but for whatever reason tonight it's kind of got this orangey hue to it, and it's not really showing as impressive as it might be. I will actually just quickly go into my list of um, okay, so let me just go into my target database list and see if I've got a slightly better picture of it that's been imaged with this exact same setup, but just on a different evening. Because as I said, it looks like it's pretty low on the horizon. And once again here, I am suffering from issues. Oh, and I don't actually have a recent M1 image either, so that's not going to help us. Okay, so
We're losing your mic.
oh, we're losing my mic. Okay. Hopefully I'm back again. So yeah. So here we are. This is the first of the Messier objects, and I think this evening this is probably as good a picture as we are going to get, albeit that this does show somewhat better on different evenings. Okay, so I think that's probably the last of the Messier objects we're going to try tonight. What we will try, assuming that I can, let's just have one more plug at a comet, shall we? Since Messier was a comet hunter.
I'm waiting to see if we have a comment of someone hearing you on the mic.
Oh, okay. Well, my mic is definitely showing as working here. So, do we see anything on the chat?
Yeah, it says low volume, hard to hear you.
Okay, I'm boosting the volume up a little bit, so hopefully that is a little better.
And thank you for all your comments out there. I have not really given a shout out to all the people who have made wonderful comments, but we will be going through this later, and thanks a million for letting us know how things are going.
Yeah, and it's unusual for me because normally I have the comment box up and running for me. So, and this is probably the first time I've done one of these live streams where I don't have the comment box. So, I got to figure out a way of organizing my equipment here in a way where perhaps I can see that comment checklist. Yeah, I think we're probably good on the sound. In fact, it looks like we're even over modulating. And I think we are going to struggle to get this comet up. I've lost my main sky map now. It doesn't appear to be responding to me anymore. So I think, well, really, considering the number of technical problems we had at Mount Helix, we've actually done quite well this evening.
Sure. What are we looking for? Which comment?
Well,
Atlas?
yes, that was the comment I was hoping to get, but I'm without the sky.
It's right near Bellatrix.
Yes.
Well positioned.
All right, hold on a second. We're gonna see if we can persuade something to work here, which at the moment I'm not sure is gonna happen. But anyway, let me see if I can maybe tweak a few parameters here and see if I can get things to work a little bit better. Okay, image just so I got record. Yeah, I don't know what's happened here again, Dave, but I'm definitely my controls have gone. I think I think I am probably at the point now where the memory on my laptop has finally just filled up, and it's like I don't want to play anymore.
Yeah, we're
Um,
now at 9:21. So
we are at 9:21, so we're already 2 hours into this, and it's probably going to take me 3 or 4 hours to thaw out afterwards. I'm not even sure at the moment whether. Let me see if I can even get my final slides up here. I'm not even sure I can do that currently. Hold on 1 second. Right. Yeah. Oh, okay. So I may be able to do that. So let's transition. Okay. Yeah. So I think for this evening we are probably done. My laptop here is. Let me. I hate to not try and get this comet up because I managed to image this comet the other day, which was the first time I'd ever imaged a comet. And it would be nice to finish off with the comet, but it's just not going to happen, is it? Okay, so I think at this point, Dave, this is probably where we sign off. So I'm going to go back to I brought up my main slide deck. Let us see. Yes. So I think this is the point that Dave and I will probably say good night to you both. We are beginning to just suffer from technical problems now, which is primarily associated with my main laptop. If you're interested in learning more about the public outreach that we do, there's a number of places that you can go. The San Diego Astronomy Facebook page, obviously the main San Diego Astronomy webpage, and this will actually appear. This stream will appear on the San Diego SDAA YouTube channel, and for viewing. So if you want to go back over anything that we've discussed or seen this evening, you can obviously do that. And if you want to see further live streams that we've done in the past, those are on my channel, my YouTube channel, details of which are given on that on the slide that you're looking at. And that's another picture there of my 5-year-old, who is hopefully now safely tucked up in bed, having given her mum a hard time and forced her to drive 30 minutes out to where we were observing this evening. Never play with animals and children. Yeah, finally, we will say good night to you all. This has been the second official SDAA live stream, as we obviously cope with dealing with public outreach in the age of the pandemic. But we're managing to reach a tremendous number of people, and I'm sure this will become part of our online our program, outreach program going forward, even when we get back to our more conventional face-to-face outreach activities, which actually number around about 120 a year. The club is very active in doing public outreach. And like I said, there's information on our Facebook page. So thanks for joining myself and Dave.
And thank you all for joining us here at the OakOasis County Preserve. We appreciate the County of San Diego supporting our efforts out here, and we look to building other relationships with the parks and at least rescue some portion of our previous outreach activities. So we thank everyone very much. And we thank all of you for chatting on the side. I have not mentioned a whole lot of things that you've talked about, but we've been reading these briefly, and it's nice to see people interacting with us, even if we cannot speak in person like we used to. But anyway, and thank you, Gary, for managing the technology in this event, and hopefully we will have a few down the road. Check the SDAA website and the group for information regarding additional or future events, and I will keep try to keep everything posted in a timely fashion so that we can do that. In the meantime, you can subscribe to the SDAA YouTube site and be notified about things that we post, and go back and review most of our recent program meetings, which have been recorded and are now posted on this site as well. So if you missed any of those great program meetings where we had professionals doing wonderful presentations, go back and take a look at the SDAA YouTube site, and the recordings are there. So anyway, thank you all for participating. Thank you, Gary, and we will see you sometime down the road.
Yes, and as usual, when we come to the end of one of these events, we usually find that the technology is failing on us. And once again, I am struggling to close down the stream here. So I was hoping that we would nicely transition to a dark screen here, and at the moment I am just completely struggling to close the stream down. So whether I'm going to be able to do that, I don't know, but we will say good night to you all, and if necessary, we will start pulling plugs and stuff in order to get these software packages to respond, because they are no longer responding anymore. Okay, good night everybody, and thank you for joining, and we look forward to the next live stream event, and we hope you can join them. Good night. Yep, I completely lost everything here. Okay.
Good comments. Looks like we're still live.
Yes, I know we're still live, which is why I'm being careful what I say at the moment. Yes, I realize we're still live, and I am trying to close the stream down. And yes, I know SharpCap has stopped responding. Hopefully, if I close enough packages down here, things will start to respond. I suspect that we have just run out of memory on this laptop. Okay, so my telescope's disconnected for those of you who are still listening, of which apparently there are a couple.
Reagan says, do a cold boot.
Yes, a cold boot. I may just pull the power or disconnect the or just disconnect the Wi-Fi here in a few moments if I can't make any significant progress in turning this thing down. Well, it doesn't impact the recording per se. I mean, it kind of mucks up the end of it, but the bigger issue is, I'm never too sure how YouTube just reacts to the fact that I disconnect